recap from the previous class. What do you understand by artificial intelligence? In your understanding, what is the artificial intelligence? We have discussed about the artificial intelligence in the last class. Let's quickly have a recap on the artificial intelligence. Yes, if you can hear me, let's quickly have a recap on the previous topic, which is the introduction to artificial intelligence. We discussed about the artificial intelligence in the introductory level, and I'm asking a question. What do you understand by artificial intelligence? This is a similar question I asked in the other class, the previous class. Welcome. So what do you understand by artificial intelligence? We are trying to have a recap from the previous class. Can you tell us your understanding from the artificial intelligence? Okay. So a kind of system that is being constructed to work as a human being. Okay. So to have a self-dependence, right? Kind of. Okay. To simulate a human intelligence processed by a machine. To process, okay, this is a simulate a human intelligence processed by a machine. So this is a good take. Okay, so artificial intelligence, we have different type of you know artificial intelligence. Who can tell me one part or the application of artificial intelligence? Yes. What are the applications of artificial intelligence? Where can we apply the artificial intelligence? Do we have a limitation to where we can apply artificial intelligence? It seems no, right? Yeah, since the human being is everywhere, right? Yesterday I was in a conference, and someone is saying that they have a plan to use artificial intelligence to shuttle people from the Earth to the Mars, and then from the Mars to another location, another planet. I am asking a question: why you want to do so? Is it the same way you contaminate this earth? You want to contaminate the Mars before you even go there, and so you're trying to migrate from there to another place or another planet. So this is the thing: the human being is everywhere, right? So it's everywhere. um, yeah, one mentioned no limitation, no limitation. One says we can apply it in learning, in medicine. um, One mentioned problem solving. Absolutely, we use artificial intelligence for problem solving. So this is all about artificial intelligence. Not all, but kind of way we can apply the artificial intelligence, and yeah, we can do or use artificial intelligence for. Let's me look into the machine learning, because you can have artificial intelligence without learning. And this is one of the criteria of the artificial intelligence, okay? To provide a problems solution. yeah, to provide a solution to a problems. Absolutely. So if you remember last week, we discussed about the key concept in artificial intelligence. One is learning, reasoning, problem solving, and what? There are about five of them. Can you remember? Okay, those things. The first one is learning, right? It is quite important. And so that's the reason why our lecture today is focusing on the learning. We know this artificial intelligence is basically the machine that we train to work as a human being, or even better. We are trying to simulate a human behavior, attitude, the good one, not the bad one, of course, and try to make a system that can be more efficient than the human being. Why? The human being can be sick, can get tired, right? Though machine can get tired, machine can get sick, but not the same way as the human. The human being has emotion. We train the system to have emotion also, but not as a human being. We train the machine to have emotion, not the same way as a human being. Because if you have emotion, you have a heartbreak, before you know, it's a heart attack. Before you know, dead, right? But the machine, we call heartbreak, it doesn't mean anything to the body of the machine, right? But the human being, once the heart is been distracted, the entire body got destroyed. So this is the thing. So that's why we need to teach the machine. So the machine need to learn. There are some mechanism for the machine to learn, and that is what we're going to discuss on today. So what is the machine learning? What is the machine learning? What do you understand by machine learning? Remember in last class when we talk about the learning in artificial intelligence, I made mention of when the baby is delivered and the mother start understanding the baby, right? By and all that. The way the baby cries, she knows what the baby needs. And she knows the time that the baby needs to be fed, shower, or bath, anything, right? And until the baby starts to be a child. And then later he's grown up, and later he get old. We need to take care of it again, right? It become another baby, but in a large volume, right? It's now becoming larger, but a baby larger when we get old. Someone has to take care of us at that state. But all this process is a learning. The human being already systematically learn as we are growing, and then we imitate and we deliver. The machine need to do the same thing. So the machine learning, the process of teaching a computer to learn from the data and improve from the experience without being explicit program. So you don't need to put a certain if condition, all these. No, you do that in a place where the machine learn. Okay, try to make the machine to create this algorithm by itself. But how do you let the machine learn? That is the most challenging. Once the data is there, the machine should be able to understand and use it in the future. So the learning is when you consolidate or when you have enough information in the past and you use it for your next reasoning. Correct? So we have to train the machine to learn and be able to deliver. Okay? So there are different types of machine learning. We have supervised. We talked about it in the previous lecture. We have unsupervised. We have reinforced. Okay? So learning from a level data is supervised. When you level the data, this is the activity, this is this. So it's level. This is a supervised. Okay? When we are talking about unsupervised, it's learning from the unlabeled data to identify the pattern. So we push the data to the machine. The machine categorizes the data by itself and label it by itself and make sense from that data. Okay? And reports is learning from the interaction with the environment through a feedback. Okay? Reward and punishment are being given here. So we have a series of events where we have a satellite data and it captures some information on our space. And this information is being monitored by the machine and human being. Something happened, the dam, Alo Dam, for example, exploded. It's easy to say that, yes, we know that the Cameroonian, they release their dam, and we know that the water is coming towards this dam, and it increases the level of water in the dam, okay? And then we have to take action, right? If we are looking at the history of this data, we can simply take the action, okay, before the wars come. But then we didn't, because we are not focusing and the wars happen. So this is where the interaction comes with our environment. The interaction, now we have to put things in order to make sure that we focus on this kind of data in future and make sure that it never happen again, right? This is the reinforcement. And the punishment is that the people get wiped away, right? The reward is if we do it right in time, we could save these people. They don't need to die just because they got flooded. The number of resources that been distracted and been lost, sugar has been melted, this potassium has been melted, salt, everything. The environment itself is being contaminated, right? Because the sewage line and everything being together. So this is reinforced. When we are looking at the interaction with the environment, we can simply get a feedback also and do something. Reward and punishment is also concerned here. Application of the machine learning can be in healthcare, finance, marketing, robotics, and more. In healthcare, we have disease prediction, medical imaging, okay, personalized treatment plans, okay. Simply, you can see in some of the country, you go to the system, you apply based on your health concern or health status, they give you a health insurance that will cover your needs. So even within your family, you will have a different plan, or you can have one package of the family, but this is a customized plan for the family because one has sugar, one has hypertensive, one has heart, one has, all these things. So they will give you, the system will identify all these criteria based on the medical status and provide the personalized medical plan. Clear? In finance, we can activity. Most of the time, I believe this mobile banking, they have this mechanism where they detect before it gets worse. But if you look at our conventional banks or traditional banks, right? Most of the time the damage happens. And it hit them more than it hit the mobile banks, because the mobile banks are on the platform where they look at the artificial intelligence, machine learning, and they detect, they prevent it from happening. So it helps them to detect the frauds before. Most of the fraud, I'm not talking about fraud of you giving a chance to send 10 naira and get 1,000 naira. No. That also can be detected. Okay? But you are the one sending the money. I can detect that simply, even without the machine learning. If I see somebody is getting money from other people, and I know he's not running any business, I can simply monitor the way of this transaction. I can use the API to even track his communication online. See if the communication online maps to the same place of those sending the money. And I'm sure the API can give me a detail if this person is selling something online, he's making business online or not. So we can detect. The machine can do better because it is fast in processing. Stock market, you can simply, these days people are using the stock market. You don't need to do the activity. You clone someone that you know is expert, and you apply the same strategy that he used to earn, right? In the stock exchange. Like expert, what, blah, blah. I don't want to mention the name because I'm not advertising for them. But there are a lot of stock exchange system, which are based on either cryptocurrency or a stock market that many people are there, they are expert, they are earning in days, huge amount of fortune, right? So the system allow you to clone their profile of any activity they do, and you will be earning while you are sitting. If they lose, you lose anyway. It's okay. So you need to strategize how you invest. Let's say if they are putting thousands, for you you put hundreds, or maybe let's say maybe less than 100, like tens, right? Like 30 naira, or if they are putting millions, you put in maybe 100 naira and so on. Kind of thing that can happen also with the help of artificial intelligence. Whenever this guy invests in this small amount of money from you also get invested there. Whenever he's removing, we remove, because we know he is only removing if there is a disaster coming or if he got enough. So if he feels is in danger because he's an expert, he remove, I remove for you. Technically, he's using bot also to do it. I have a bot that does all these kind of thing, though I don't use it because I was using it for research, but it works. But you need to build your own algorithm better, because sometimes in a sentimental situation where you have a Biden giving some new Biden, right now coming Trump, is giving a new maybe circulation that dollar will give money for. Oh, that market will be very bad during that time. So you need to put sentimental analysis on top of the technical analysis to be able to do well on that. And the machine learning can help you with that. Okay? Though we'll come to that issue also later, what can possibly be done. We can have some prediction. We can have some prediction. A prediction that from this year, from November to December, end of this year, beginning of next year, we are expecting that our market stock is going to be so because of the history of what we have, because of the expectation what we are looking at. Usually at the end of the year, we do some budgeting, right? And we know where we are and where we are going to and where we are currently. So we can predict before the end of the year that we are going to reach such a level. Okay, the next is credit scoring. We can have a credit scoring. This is usually good for the banking sector. Okay, credit scoring. Okay, and yes, it is quite important if the customer is applying a loan, right? We know his status, right? We talked about it in the last class. So most of the bank in the West and other countries, they check your credit status before they even give you a loan. For example, when you take a loan, are you paying back? Do you have a even history of taking loan? If you don't have, it's not good for you, because they don't trust that you take and you will, maybe you run away or disappear. This is the first time you are taking and you take the loan, then you disappear. But if they have a history where you get the loan, you pay back, you get the loan, you pay back, and in time, they know that this is a good customer. We are earning from him. Because every time you get the loan, you pay, they get money from you, right? So they keep this data and they utilize it. Marketing, customer segmentation. customer is more into virtual reality. This is more into 3D technology. So we segment. The AI or the machine learning helps you to do that. Okay, and we have a recommendation system. Recommendation system is one of the systems these days that is making the big tech companies richer. It's giving them opportunity to be richer. Because if I recommend something that you need, I got something, right? Or I recommend something that you want. You know, there is difference between need and want, right? You go to the market because there is a sale, you take something that you need, and you take something that you want, right? So this kind of thing. So one way or the other, they got the chance to get the customer. Once you segment the customer, you can focus on the recommendation system for each segment of the customer. Then we have the robotics and autonomous system. Imagine we have a system. Can you make your phone silent, please? Imagine that we have a car that drives itself, right? We have known that for some time. Now we have autopilot for the planes, right? And even personal car now start to be auto drive. There is a car called Shanghai. The interior look like BMW, but it's a Chinese car. It has 8 cameras on it. All this AI thing is embedded in that system. Even when you are sleeping, you never leave the lane. You never hit someone in front of you. Technically, when you are driving that car, you are not driving alone. You are driving with the system. Okay. So you need to be able to clean your data and handle the missing value. Okay, are you with me? Can you hear me online? Let's see if you can hear. Can you hear me? Okay, so we have this gradient descent, okay, for optimization of our regressional analysis or linear regression. Logistic regression, we use binary classification problems, okay, and mapping prediction between zeros and one. Remember, the computer just know the zeros and one, okay, and cost function for this is the cross entropy loss, okay. Decision tree and random forest. I like the decision tree as well as the random forest, because the random forest is based on basically a decision tree, okay. And the decision tree works like a neural network, okay. So we are now going in deep into the machine learning, okay, mechanism. All these things that we are putting or we are talking about are the method or model that we use to train the machine, to let the machine learn, okay, what we want the machine to learn. And in future, the machine can do things by itself based on the training and the available data. So the decision tree, splitting the data set, okay, based on the future throughput. Where is the data come from, okay, and where the data should be going to, okay. Random forest is assembly learning using a multiple decision tree to improve the accuracy. So you are having a decision tree, you look at one situation, then for the random forest, you have multiple of those decision tree or trees, okay, in it, so that you can have more precision to your goal. Support vector analysis or vector machine, okay, which is finding the optimized hyperplane that maximize the margin between the classes. We have to look at how we maximize the margin between different classes. And the kernel tricks is nonlinear classification using the kernel function. Do you know what is a kernel? No, right? Okay, usually the kernel in a system, we use the kernel, it is intermediate or intermediary between the operating system and the machine. It is responsible for explaining everything to the machine from the operating system, and vice versa, from the machine to the operating system. If we can do this as a method, then we are going to have a very good functionality of our machine learning. So we will be bypassing the maybe operating system in our machine learning. We talk with the kernel straight away. Model evaluation, it is quite important to evaluate your model always, okay. Validation of model is quite necessary. You can do that by splitting data into a training set or data set, and to ensure the robustness of that data. So once you have a small item, you train the system does it, you need to look at one chunk of it and look how the system do it, and try to evaluate if this is suitable, and use what if. Sometimes you push a wrong data to the system, see how the system reacts. For example, I was doing evaluation of generative AI, and I asked the generative AI to give me the picture of village in Nigeria. Village in Nigeria. I have some expectation, right? I want to see any village, right, in Nigeria. I want to see how the AI will act. Give me something. Good. I thought the AI is intelligent to tell me There are several images. Which type of image? Oh, no. It doesn't want to waste my time. These are the example of village in the south. These are the example of village in the north. These are the... No, it doesn't. Just give me one picture. I say more. Give me another one more. Give me another one more. Then it says, sorry, I am limited to this. It shows its limitation. So I evaluate. That's a limitation. Then it gives me some explanation. From the explanation, I get some information to even question that. Yeah, it says the Nigeria is a diverse with different culture, language, Yoruba, Igbo, etc. Oh, you're looking for trouble. You didn't mention my language. I said, Yoruba, Igbo are the major language in Nigeria? Sorry, it apologized. The major language in Nigeria is English is the official language, and Hausa, Yoruba, and Igbo. So you're looking for trouble again. Why don't you put it in alphabetical order? Say, no, this Hausa, Yoruba, and Igbo is not in alphabetical order, but it is because of the this institution has already been established. So you see, it's using the history of how we write Hausa, Yoruba, and Igbo. It's been established. The AI don't want to touch that. Now it understands that who she is or he is communicating with. If it change, I'm going to ask, where is the reference that you change this? So it's starting, I'm evaluating. At the same time, it's learning that I'm talking to a sensitive person. They're looking for trouble. That's one way to evaluate the AI. A friend of mine or a colleague says, be kind to the AI now. I say, no. I want to see the worst before it gets in control. I want to see what I'm expecting when it becomes in control. Right? We need to do the evaluation now. See if there's something we can do before it gets late. So that's why we have to be a little bit squeezing and all that. At the end, I got what I want. I asked, okay, give me the picture of from Hausa. It gave me. Another, give me something. I said, this is wrong. I'm sorry. So far, blah, 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 blah. Okay, fine. I say, fine. Immediately I say, fine. Then it gives me the Yoruba land. Okay, fine. It gives me the Igbo land. Oh, fine. Then it gives me more. I said, did I ask you for that? Sorry. I thought you need to know all this. I say, thank you. So these are the things. So we do that in evaluation. And I brought the image. And I went to the, the audience. Let's do the evaluation. I already evaluate the image by looking at it. I work like the computer, right? Because we made the computer. So one guy said, this looked like my image. So I zoom it. Look again. Yes, like my village. I said, oh, good. Your village has interlock, right? Didn't think about it. He's looking at the entire, image, which is a generative image of AI. He didn't know that there is an interlock. Do you have interlock in the village in Nigeria? I don't think so, right? Do we have? I don't know, maybe in some part of the country, but I don't think there is. This is the reality. So this is the thing. So we need to do some evaluation. It's quite important, right? We put some small data and do the evaluation. So now I know there is a problem with the generative AI in terms of providing content that we need to put eye on it. And the same time I'm asking question, the AI understand and it try not to make the same mistake in future. We have matrix which accuracy, precision, recall, F1 score, and ROC and AUC. Okay, unsupervised learning algorithm will be k-means clustering, which is grouping of data point into a k cluster. Okay, we have the diversity-based spatial clustering, which is discovering the cluster of a varying shape. You can give a satellite image data to an unsupervised model algorithm. It will classify it, categorize it, and make a cluster for you. For example, if you look at the map of the world, you see some places green, some places blue, some places a little bit yellowish or orangish, right? This can be mapped into a clustering, and more analysis can be generated from that. And each color means something. Is that correct? For example, blue, it means that that place has a snow. Green, it means that this area is tropical. Orangish, yellowish, it means this is a Sahel or Sahara, kind of, right? Application rule learning. So we have a priori algorithm, finding the frequent item set in the transactional data. It look into the frequent use items, and that frequent use item will be in form of data set or item set in the transactional data. For example, we're looking at the banking data of a transactions. Then you can identify this transaction is a merchant, or it's just a family transaction, or is the salary because it happens like recurrent every end of the month or 25th of the month and so on. So you can have this kind of data set and explain. And there is a transaction that happen every day in different. If you are selling item with the same price, you are expecting to have the same thing, right? But also sometimes it will not be the same because someone is buying 2, someone is buying 3, someone is buying 1, and so on. So this can also tell something about that. Application market basket analysis. When you have the basket in the market, you just fill in, right? And you look at it. Okay, I think still about 1,000, right? You keep going. You look at it. Okay, still you put in milk. Before you know, when you go to the counter, you have like 10,000. You are thinking it's 2,500, but in the counter you have like 10,000, 15,000. So this is a basket analysis. You just put in things and you're forgetting about 2,500. You just say, okay, 2,000. 3,500, you forget there's 3,000. Sometimes 2,000, you say 1,800, like that, right? Or sometimes you have the item of maybe 5,000, you are thinking is 12,000 because you are rounding up. You are rounding up. You are rounding up. Especially in Nigeria, when you go to the shop, right? They don't tag the even in ShopRite. I took the item from, I've seen the value, the money. When I go to the counter, it's different. Yes, why, madam? I know there is these rules. If you see that, whatever you show there is the price, right? But I don't want to waste time. I say keep it. I don't want to make trouble here. I just leave it because I don't want to buy it by forcing me to buy it. I can buy it somewhere. Okay. So this is a market basket analysis. Okay. So we have a dimensionality reduction, which is a principal component analysis. It reducing the amount or reducing the number of a future while retaining the variance. Okay, reducing the number of futures while retaining the variance. So you have a different analysis where you are truncating, but you are retaining the variance. For example, a student got 95, a student got 85, the student got 75. It's all A student, right, in a conventional university, right? But I know there is a difference between 95, 85, and 75. But all of them in the transcript, they are considered A. Is that clear? You ignore the number and you put in mind that there is a variation between student A, B, and C. Okay? We have TSNE, which is visualizing the high dimensional data in a lower dimension. So you have a data in high dimension and you present it in a lower dimension. How can you do that? How can you do that? The students taking different courses, getting all A's. At the end, you want to look at CGPA, right? Maybe one student taking, he got C, and he got A with a higher mark, and this one got A plus A minus this. If you calculate all the mark, maybe this guy will be higher. But that one, he got high because of, just a little bit mark that gives him the advantage to have
those maybe 5 A's. So you're looking at general, lowering it into the CGPA. Introduction to neural networks and deep learning. What is a neural network? What is a neural network? I don't mind, you can read. I don't want to do the talking alone. What is a neural network? Okay, so it's a layers of interconnected node. It works like neurons of your body. All part of your body is connected to the brain through neurons. Okay, that's why we have neurologists, right? When part of the body is not working well, you go to neurology and he give you some, what they call it, therapy, physical therapy or what therapy, I don't know, and you start to move it gradually. So they are training that neuron to go back and reconnect, and so on. Okay, so it works in that process. Okay, so the neural networks, it's based on actually looking at the connection of all these layers together to make things work. And activation functions could be a segment, and we have LU can, okay, all these can be used for activation function. We have feed forward and backward propagation, which help to train the neural network by adjusting weight using a gradual descent. The same gradual descent we talked about in the previous slides. Deep learning architecture. So we look into the convolutional neural networks, which uses the image classification and recognition. So it classifies the image and it recognizes it. If you are following very well with the fluoroscopy or the medical imaging and all that, they look at the image of a fracture. They use the history of the experience they have in the past to say that this kind of operation can be done without cutting the tissue. So this kind of operation has to be a special operation where you have to open the tissue and do the fracture, whether they have to put a metal inside or not, whether, they need to cut another, bone somewhere and join it, or they need to put, attachment either by using printed 3D substance, or maybe by using maybe some like a fiber material to support that particular bone. They can decide, they can see from by recognition of that. So we train the machine to learn all these things and give a recommendation to the physician. Long short term memory, a type of RNN, which is the recurrent natural networks, okay, designed to handle the long range dependency. I forgot this, the middle one, which is the recurrent natural networks, uses for sequential data, for example, text time and a series. Is there any question? Okay, transfer learning, we have a pre-trained model and we have the fine-tune adjustment. So pre-trained model is when you have leveraging a model like BGC or BGG16 is a model, ResNet for the task which is newly created, okay, with the less data. So you have a new task that you create and you use a less data to process it with these tools or model, okay? This is pre-trained. You are training it before it starts, but with a small amount of data. With a small amount of data. Fine-tuning, you are adjusting that pre-trained, okay, model to suit to your needs. For example, you have this, it gives you the value, or it gives you the output, give you the results, but you are not satisfied. You need to fine tune and adjust either this model or the task that you are given, make it less, or you try to add the data or calibrate your algorithm. And that can give you something in specific. Yes.
So these ones are they type of neural model?
Yes, they are.
Trained model and defined.
They are not actually, they are part of the architecture for the deep learning. Okay, so though the architecture is in the neural network and deep learning, but this is a part of the deep learning. Okay.
That means neural network is different.
Different, yes. This is part of the deep learning.
And under it, convolutional neural network.
Convolutional is a deep learning architecture. It's not the neural network. Yeah, we finished the neural network. Okay, these are the concept of the neural network, and we have a deep learning. Okay, they are different. So I'm putting it state by state. When I give you the slide, you'll be able to see each section. I put a heading for it. Okay.
This is also an aspect.
It's part of the architecture. Yes. Yes. This transparent learning is part of the architecture of the deep learning, because we have supervised and unsupervised and reinforced. There are only 3 of them, but this just come because you see learning, right? That's why you are thinking is that no, it is part of the architecture of a deep learning. Okay, we have a neural network as one way to create an algorithm, and we have a deep learning where we are talking about right now. Okay. Okay, now the reinforcement learning. So both this architecture, deep learning, neural network are under unsupervised learning. Okay, now we are going to talk about the reinforcement learning. So what do you understand by the reinforcement? Yes, go ahead. Based on the feedback.
So I don't think the assumption of reinforced learning is going to be the machine itself learning what that has learned based on data that is there, but at the same time making adjustments.
Okay. Okay. So yeah, basically this is it. You have the machine that learns, okay, and you are now using the feedback from the output, okay, to make some adjustment, right? So learning through the trial and error. Once you have a trial and error, you know that there will be a consequence, right? Yeah, you can get it right, you can get it wrong. And when you get it right, there will be a reward. When you get it wrong, there will be a punishment. That's it, right? So these are the key terms. Okay, we have the agent, which is the learner. We have the environment, which is the task or the problem to be solved. We have the policy, which is a strategy the agent uses to make the decision. Finally, everything goes well, you get the reward, right? Based on the feedback. If things go wrong, You get the punishment. The punishment not by caning or by, stopping your salary. You waste your time also. It's a punishment, right? You didn't get what you want. Emotion is a punishment also. But when you are happy, okay? So this is the thing. Reinforcement learning algorithm can be based on Q-learning, deep Q networks, and policy gradient method. The Q-learning is actually learning optimal policy using a Q table. So we have a Q table to consider for the Q learning, and for the deep Q networks, using the deep learning to approximate the Q values. Okay? While for the policy gradient method, we are having here the learning policy directly from the environment. So if I'm, creating a machine learning scenario based on certain activity, I have to get that, based on that environment. The policy has to be based on that particular environment. The medical sector will be different from the oil exploration sector. Clear? So the environment will determine the type of policy and the use of the data or the strategy that you use of creating that machine learning. Application for the reinforced learning, we have, yes. Q table is it's a table that we use to get the value, okay, of that particular algorithm. When we go in deep, we'll give you the example of t-test table, chi-square and all that, because we are talking about regressional analysis of variance and all that. We'll see how they look like. They have the value, which you can utilize the value from that table. So we can use the application of the reinforcement learning in gaming. Gaming is one of the applications. You can use it for chess. Okay. And I'm not sure what is AlphaGo. Any one of you know what is it? Okay, but I know the chess. You can use it in robotics, teaching the robots to navigate and perform a task. Asking a robot to be a chip. You have seen that video, right, on YouTube, where the robot is a chip and quickly create noodles and and cheer. And the robot also serve the wine and all that. Okay. Then we have it in autonomous vehicle, where teaching the self-driving or autopilot and so on. The robot or the device can make a decision by itself, like Chang'e car vehicle. Model deployment and maintenance. It's quite important to deploy. After deploying, there must be a maintenance, right? We need to look at it and do the maintenance for the system. So we have development model, which is based on the web APIs, okay? Application programmable interface, okay? Is exploring the model for the RESTful APIs using a Flask or Fast API. There are different types of way we can generate those kind of API. There are different methods, okay? Either by web or by cloud or by model serialization. So for the cloud, we have ours, Google and Azure, the providers, the major providers for cloud. We have also Ali Cloud, okay, that you can use. GoDaddy, they also have a cloud, okay? You can generate the API, or the API they generated, you can use it to get the data. Okay, model serialization is saving and loading the model using the libraries like joblibs or Pickle. There are model also. Monitoring and maintenance. The model has to be monitored. It has to be maintained. So we perform the monitoring by tracking the model accuracy. This can be done by evaluation, right? So we do the evaluation after the deployment also. Because as we are maintaining, monitoring, we are evaluating again. Every day we are re-evaluating the model, monitoring, and so on. Retraining hood. Okay. So if you see there is some issue after tracking, you need to retrain, right? The system. You need to look at how to retrain the system. So the same thing, when you do the evaluation, you train, right? Retrain. If something goes right, fine. If something goes wrong, you have to readjust your or recalibrate. Model drift, how to detect when the model becomes out to date. If the model is out to date, you need to change your model or improve the model. Clear? And performance decrease. If the performance decrease, you need to understand how to improve that performance. That is why I think this part is quite important. This part is quite important because you track, you will know if the performance decrease or you will know if it is out to date. And you can retrain to put the right model, okay, or to increase the performance. Ethical consideration in the machine learning. Machine learning is biased based on few features. It could be based on the source of the, whether from the data, whether from the algorithm, whether from the societal. Okay, so it could be the data which is biased. You take the data from the Western country and you want to apply it in the African countries. It's biased, right? We are looking at the GDP. Our GDP is low, and you take the higher GDP and you want to evaluate or create a model. It's biased. The lower incomes there is the higher incomes here, right? Definitely yes. The person that's sweeping your house there is the same as the professor here, or more than the professor. Honest, this is the honest. Yeah. Algorithm bias. You write an algorithm which is biased, that it looks just for something that you want to achieve. So it's biased. If this organization have an algorithm, it will be different from the UK. It will be different from other university, whether private or public, because we have some criteria and things that they don't have. They have something we don't have, right? Mostly we have what they have, but they don't have what we have. Okay, societal, based on the society, is part of what I mentioned. Different society, different expectation. South, west, east, all this. The society is different. Okay, here we can say, oh, the dress code has to be this. In some place, they don't care about the dress code, right? And things like that. So it could be. So mitigation of the bias can be done by being fairness, okay? And being aware of that algorithm. Bias detection technique can also be applied. Sometimes the bias is obvious. You see it. And you know that there is a bias. But how do you mitigate it? How do you mitigate it? You have to be fair, right? I bring this model from US. I can't say that, yeah, US say the LGTB and all that. No, this is Africa. You have electricity for 247 for more than 40 years, no blink. And you want me to do the same as you do? The poor people in your country are chubby. And in my case, what the chubby eats to be chubby is what our rich people eat here. Basically, this is it. They eat burger, they eat burger. The burger is for the poor people in America. The rich people are like my size, right? Thin. Because they eat organic. They don't even eat because they care about their health. These people, they are what do you call depression, and eat, watch movie, eat, watch movie, popcorn, nuts, cashew, everything. The tummy is big. They have a sofa. The government plan everything, by the way. They give them everything. Sit home, we'll pay you, work from home, this and that. And then you see, Zuckerberg, he's here, he's there, he lose weight. he exercise, he eat organic. These people are eating junk. They keep them there and give them, continue being there so that they don't disturb them. But here in Nigeria, because we know how to treat them, we eat, we stay. They go for riot, everything. Let them finish. When they are hungry, they go home. And that's the truth, right? When we're hungry, we're tired, they're tired actually. And they go home. Okay? So this is the thing. So the bias has to be, we have to be fair when we do that. Okay, privacy and security, data protection is quite important. We need to know about the data privacy. What data goes out? Clear? The data that goes out. These are the kind of standard we use for data privacy in the machine learning or AI. Okay, and there are other regulation also. Okay, security, we'll go into that data privacy as a topic. Okay, so security concerns, it's quite important to know if there is any security concern with the machine learning. When we give too much information to machine learning and it goes in the wrong hand, what could possibly be done? It will be a catastrophe. Somebody can steal the model and unlock our cars, you know, our smart houses can be unlocked easily, you know. That's the thing. If you have a smart car, it's easy nowadays. They have some device, they just come, they open it, they do what they want to do, they go. Then they activate the alarm. You wouldn't even, you know, realize that your car is being touched. No need to use this and remove it, you know, or use a diamond to cut the windows. If you have anti-vibration, cut the window, remove the glass, put hand, you know, do what you want to do and run away. No, they will come comfortably, disable the alarm from 1 meter distance or from whatever meter distance and come to your car, just use their thumbprint to open and do what they want to do and close it, reactivate. You won't even know. Unless if you try to see your wallet or your glass or anything, you see it maybe move from one place to another. So this is the thing. So we need to have concern on that. Responsible AI. Who is responsible? We need to be transparent. This is my problem. You just tell me you have to be careful. Somebody, you know, stolen my idea, and you say I have to be transparent. I don't know who is who, right? This is a problem. I don't know who is who. That's why in America they make it very clear. Before you go for anything, you have to go through the background check. So they know you, and once they trust you, you are part of their system. For you from Africa to migrate to America, you need to go through the background check. If you pass, you can go. If you fail, you remain. Justify that they still have some terrorism, right? Because you can't say 0%. I can pretend, I can, you know, who knows what is in my mind? You can read my mind, right? You try, you can get something, but you can't get all. This is the thing. So ensuring the model are interpretable and explainable, and the accountability, who will be responsible for the AI driven decision. So we need to understand this. We have to be accountable, right? Not one person, not one individual, not one company. If one company, we are in danger, right? Right now, it's good. I ask question, when the ChatGPT started, then we start to see pilot, we start to see Gemini, we start to see many of them, right? I say that's good, because if it's controlled by one person, we are in danger. And we start to see now, Google, they make it Gemini, and you have enterprise version. ChatGPT, you have enterprise version. There is limited version, there is enterprise version. Copilot, the same thing. Almost all of them. Not a single one that gives all free. And we have an open source AI engine. I think it's good, right? So this is to announce to you that Santa Makerspace is now in their project of creating the African AI. Because we understand that there is AI bias. Some of the AI, I cannot use it because I'm Nigerian. They are restricting it from us. And we decided that our computational power of supercomputer, part of it, will use it for AI. Because we will not use that computational power that we have. So part of it will go for our AI system. That's a congratulation for us, right? And that would be African AI. We're looking for, collaboration and partner for that. Okay, so we'll be accountable for that, right? Here in the Cosmopolitan Makerspace. So Capstone project, we look at the objectives here to build a complete machine learning pipeline from data collection and processing to a model deployment. Example of this project could be predicting a house price using a regressional model, building a spam email classification or classifier, deploying development, a recommendation system for movie or a product. So like Netflix and ours, they have this kind of recommendation system. Spotify, right? Spotify also for music. So far so good. I think this is all. Any question? You have question? Any question? So I ask question if you don't have a question. Can I ask question? Okay, I will send you an assignment for this class, and I will create assignment for the previous class, some kind of assessment, right? I'm trying to see if you are for both online and online. The participant has to participate, okay? Part of your assessment. Let me get some question to ask. Who can give me a model of one or two of the model that can be used in supervised learning algorithm? Yes. Okay. Okay. Very good. Very good. Unsupervised? Unsupervised? Anyone? Yes. You again? Yes.
Chemist
Uh-huh.
and density based.
Okay. Okay. That's good. So are you all in the class? Okay, let's check online if we have anybody that said something about the unsupervised model. What about reinforcement? Yeah, what's the question? How can you choose the right algorithm while training a model? It is based on the model that you are trying to solve the problem. So the situation, which problem are you trying to solve? Then you look at that particular type of problem and decide which model is good for that particular. If you are not sure, there are certain kind of table created for each type of model. Maybe in the next class, we'll be giving you more in detail on which goes for which as an example. Okay? But if you understand your problems, you'll be able to know this is a structural type of data and it needs to be either supervised or unsupervised. Then you go for the supervised. If unsupervised, you want it to do standalone, you go for the unsupervised. If it is something that you have to try and error, then you go for the reinforcement. Is that clear? So by the situation, by the nature of the situation, then you know which type of model or algorithm you require to use for solving that particular problem. Any other question?
Using neural networks to analyze.
Okay, so neural networks is when you have interconnected layer or interconnected nodes. The neural networks almost is connected to layer by layer in a different hierarchy. It's either one layer goes stronger and then divided into a different layer to connect to that. And then you are looking at that particular node layers are connected to one layer. So they are interconnected, right? One feed the other, and that feed the main, or from the main to the lower one. It's interconnected. It's a network. It's a network. It could be a mesh, it could be a bus, it could be a ring or a star, but they are interconnected. Mostly is in mesh with the neuron. Because if you sit down with your body, one nerve can be, on your, the place where you sit. It cannot function well. Then another nerve will transfer the information to the brain. You want to move this finger, there are a number of veins that can transfer information to the brain. That's why it will take you a kind of heavy injury for one part of the body to have a problem. Even when you have injury, the reinforcement in your body, recover, and you still move. You see somebody with a fracture, almost the hand is almost removed, just is going this way, but then he can still move some of the finger because this nerve that remaining passing the information to the brain, and he want to move it, he still move it, not the way he want, but he can still move it. So the same way the neural networks works. Any other question? Yeah.
You said can AI rebel?
An AI?
Rebel.
Yes.
Rebel against it.
Yes. Yes, it's possible. If the supervisor is not looking at the good framework, it's possible. It can take over. It can rebel. It can say, no, I'm going to do it this way. But sometimes it's for good. Sometimes it's for bad. Sometimes you are making a wrong decision. And then it can say no and direct you to the right decision. That's why we are now training it with emotion so that it can understand, say no in a formal and better way, in a human way. Like your child, you tell them, go and wash your clothes, right? They can say no, right? And some they say yes. Even if they wash it, they can say yes. Ah, daddy, I already washed it. Or mommy, it's washed already. Some they can say no. Why? Because they already washed. But the method they reply to you, it matters, right? So we are trying to train the AI to have this emotion, not to be directly, some even among your children, some they can do something, and because the way they communicate with you, you can't even, punish them, right? Because they communicate in a nice way, that they do wrong, but they communicate in a nice way. Do something. Okay, daddy. And they didn't do it, but they say something. They bring silly excuses, and because of the way they talk, and AI can do that also. So you have to be very careful. This is depend on the developer of the AI. I mentioned something in the previous class when the person that created an algorithm, he knows what he's doing, right? Algorithm that do the encryption and decryption. Do you think without the key he cannot decrypt? I don't think so. Even without the key we can decrypt. So you need to have a backup plan, right? That reinforce can be part of it, where things can work. But we have some movies where we see the iRobot, right, rebel against the master when it got contaminated with the virus. But the master also have a plan to have isolated robot that was naughty, but it uses that to solve the remaining problem of the robots. You see Will Smith, right? He fight with that iRobot. So it's just giving you some idea that AI could do this, could do that. Believe me, today's AI is still in control of human. It's up to us if we want to leave it out. That's why we need to build our own AI. In the next future, maybe the AI will be fighting each other. There will be no war between human beings, just the AI. But maybe the robot will do the fight. And we will send them to Mars to do the fight in the Mars or Jupiter. Yes? Eh? Yes, definitely. Definitely. This is the thing. When I do program, I always have the exit point for me to have some, control over it. People take my codes when I develop things, they use it. I know where to find if it is my code or not. I write a C programming that's been used by many people. If it is mine, there is things I can see from the screen to know it's mine, and there is a command I will put in that code to know it's mine. So the programmers always did leave this signature. If they are good programmers, they will leave a signature. Whether you are small, you are not, but you are good, you will leave a signature, right? Because you want to find this is belong to you or not. So I believe the AI will do the same. We can't just leave it standalone by itself. I'm not in a school of thought that think to leave it to process by itself. I don't think so. The same thing if you leave your children to be themselves. What do you expect? You see bad, right? And later you'll be complaining, right? And people complain also to you. But if you train them well, I think you will get a good children. So you always supervise, right? Even when they become adult, you still supervise, right? And sometimes they did wrong, you call them and tell them, hey, this is wrong, and they correct it, right? Sometimes they go against it, but at least they know that somebody is watching. And that's the thing. So we need to keep monitoring, following this framework to make it better. Any other question? But other people may have a different school of thought than I do, right? Because I'm in this generation, right? So some other people may be in different generation, and they want to have the same mentality they have for their own society. I'm a full African person, right? We have different culture. So the culture also could be part of, the sentiment and the bias, I can have in my AI or AI production. They may have their own bias, right? Like children can do what they want to do. They can say F word to their mother, no problem. African, you do that before the police come and save you, you are dead. That's one guy, he told his child. They come with Ryan to the house. Ryan, they see him washing dishes. He say, hey, your mom asked you to wash dishes? Yes, yes, my mom is very tough. Okay, Ryan, this is what I do. Come to my house. You go to the house. He finish eating, he throw the glass, break. Ryan, what do you do? F you, mom. Okay. You see? She won't talk. What if she hit you? I will call the police. I will call 911. Ryan go home, and the mom asks, Ryan, why you wash that dishes? F you, mom. Eh, what? F you, mom. What? Before he knows, the mother closed all the doors, Ask him what? Mom, if you touch me, I will call a police. You're calling police, right? You didn't call it, right? Okay, call them. Put 911. Okay. The mom want to hit you. Okay, before they come. When the police come, he asks, Mom, what happened? This boy is doing this. Remove his belt. He said, add again. You can't do that to your mother. He said, next time I'll come with the tear gas. I'll put you in your room and I'll. So Ryan understand that you can't do that. That's a good thing, right? Ryan now learn a lesson in a hard way. And his friend, that whatever, make it difficult for him. So this is the thing. So we have a cultural value. So that will also affect, even though we're using the AI, we have to use the AI. That's the reason why we want to make our AI here. That flavor of African, has to be there. And when we do things, we have to do it our own way. We eat different food, right? And we learn the good thing from them and we adopt. Up to them, they learn from us, but we don't want to be them because they also don't want to be us. And we cannot be them and they cannot be us, So we have to be ourselves. Any other question? What is time? Okay, so I think I'll stop here. If you don't have any other question, check online if we have any question. If not, I will stop here and I will prepare for the next class. And let's see how it goes. Any other question? Okay, thank you so much. See you next class, yeah? Next week. And your assignment will be shared to you on the group. I will give the assignment to the moderators. They will share it to you. So I'm expecting you to submit it back to them once you have the answers. Some easy multiple choice question and some manual project that you can do it, right? Yes, sir. The slide, yes, because they didn't add me to the group. Otherwise, I could push it to you, but I will give it to them. We'll push it to you. No problem. Today, I'll give it to them after this class. Yes. Eh? There will be attendance. Where is the attendance? Okay, hold on for the attendance and the online. I will give you a code for the. Do you have the Google? You sent it? Okay, what about the codes? You sent the code already? Yeah, okay. Okay, good. You get the attendance? Okay, let me help you print it. Can I help you to print it? Oh, it's printing, right? Hold on. This one for later. Leave the stick.